Hello everyone, let us see today how to find the limit of a real function. Let us take first a function whose nature does not change throughout its domain. Let us say I have a function f of x is equal to, let us say x minus 3 whole square plus 2. Let us say in the whole domain from negative infinity to plus infinity, the nature of this function does not change. It's the function that remains the same from minus infinity to plus infinity. Let us say the graph of this function is like this. And if we have to find the limit of this kind of function whose nature does not change in the domain at any point, let us say at a point I have to find, let us say this x-axis is equal to the domain, y-axis is equal to the range, and I have to find the domain of this function, let us say at this particular point k. Since the nature of this function does not change, so if I see both at the left hand and the right hand of this point k, I will see that both at left hand the nature will be same and at the right hand the nature will be same. So in this case, if we have find the limit of a function, we will not find the left hand limit and right hand limit. What we will do, we will directly find the limit x tends to k f of x so as to get the limit value without finding the left hand and right hand limit in this case. So this is the case for that function whose nature does not change at any point in the domain. So now if we have a function, let us say I have a function whose nature changes. Let us say its nature is 1 from negative infinity to k, and after k it has a second nature. Let us say from minus infinity to k the function is like this. Let us say the function is f of x is equal to x minus 3 whole square plus 2, and let us say up to point k. So from negative infinity to k it has this nature. Let's say this is the point k, this is point k, and after k, let us say its nature is different. Let us say it is after k, the nature of the function is g of x is equal to negative 2x plus 10. So if I see at this point k, I will see that at the left end of this point the nature of the function is this, while at the right end the nature of the function is this. So its nature is changing both at left and right. In this case, if we have to find the limit of this function, we will find the left hand limit x tends to k negative f of x, and we'll find the right hand limit x tends to k plus g of x, and we'll check whether they are equal or not. If they are equal, then the limit of this function exists, and if they have the value, let's say z, we will say that the limit of this function exists and its value is equal to z. If the left hand and right hand limit they are not equal, we will say the limit of this function does not exist at this particular point. So this is the way of finding the limits of the real functions. Now let us do one of the questions that will come in JEE Advanced. Here we have a question: let x naught be a real number where x naught is a real number such that e raised by x naught plus x naught is equal to 0. For a given real number alpha is a real number, we are given a function g of x is equal to 3x e raised by x plus 3x minus alpha times e raised by x minus alpha x divided by 3 times e raised by x plus 1 for all real numbers x. Then which of the following statements is true? We are given 4 statements, we have to check which one is true. In these statements we see we have to find the limit x tends to x naught for this particular expression g of x mod of g of x plus e raised by x naught divided by x and x naught. Let us first, without using alpha and without using limit, we'll first simplify this expression. We'll see what we'll get. So the expression is mod of g of x plus e raised by x naught divided by x minus x naught. So let's put the value here. For the g of x, we have the value 3x e raised by x, 3x e raised by x, 3x e raised by x plus 3x plus 3x. Then we have negative alpha e raised by x, negative alpha e raised by x Then we have negative alpha x divided by 3 times e raised to x plus 1, 3 times e raised to x plus 1 plus e raised to x naught whole divided by x minus x naught. So let's put 1 here and let's cross multiply here. So if we see the first two terms, we can put 3x common. So it will be mod of, we'll put 3x common, we'll get e raised power x plus 1, and in the third and fourth term we can put negative alpha out. Let's put this negative alpha out, we'll get e raised power x plus x, then multiplying 3 times e raised power x plus 1 with e raised power x naught, we'll get plus 3 e raised power x naught times e raised power x plus 1 divided by x minus x naught times 3 into e raised power x plus 1. So this will get, if we see now the first and third term, we can see that 3 times e raised power x plus 1 is the highest common factor between first and third term. Let us put it out. So we'll get equal to, we'll put it out 3 times e raised power x plus 1. Let us put it common, and we'll see that in the first term we will remain with x, while in the third term we will remain with e raised power x naught. So we'll get e raised power x naught plus x, e raised power x naught plus x negative alpha times e raised power x plus x, alpha times e raised power x plus x divided by x minus x naught times 3 times e raised power x plus 1. Now we have to find the limit of this expression when limit x tends to x naught. When x tends to x naught, we have to find the value. And we have to also use the value, and we have to check whether alpha is equal to 2 or alpha is equal to 3. Let us first see what, if we put the limit, what happens. So when x tends to x naught, if we see x tends to x naught, then this term e raised power x naught plus x, it will become e raised power x naught plus x naught, and we are given that its value is equal to 0. In the question we are given that this quantity is equal to 0. So it means that then this first term will become 0, because if it is 0, 0 times anything is 0. Similarly, it will become e raised power x naught plus x naught, it becomes 0. So the whole numerator becomes 0. If we check denominator, we have, when we put x tends to x naught, this term becomes 0, 0 times is 0, so we'll get again 0. So it means that this expression, when we put the limit x tends to x naught, this whole expression becomes the form 0 by 0 form. So it is an indeterminate form. Now to solve this indeterminate form, we will use the L'Hopital rule. So what the rule says? It says if we have any expression, any rational expression in indeterminate form, whether infinity by infinity or 0 by 0 form, we will differentiate numerator and denominator separately, independently. So we will differentiate numerator independently and also denominator separately. Let us differentiate them. So first let us differentiate the numerator. If we see that this expression, let us put it u, let us put it v. So we'll have uv rule. So we'll use the product rule, uv rule. So we'll get mod of 3 times. Let us differentiate first u. The differentiation of u will be e raised power x times, keeping v same. So the v is e raised power x naught plus x, e raised power x naught plus x, plus now differentiating v. Its differentiation will be, we know e raised power x naught is a real number. Let us say x naught is 3, 4. So it will be e raised power 3, e raised power 4, some number. Its differentiation will be 0. We are remaining with x, the differentiation of x is 1, so it means the differentiation of v will be 1. So it will be 1 times, keeping u same, that's e raised to power x plus 1. So it will be e raised to power x plus 1. And now we'll differentiate the next second term, that is negative alpha, that's constant. Negative alpha times if we differentiate e raised to power x, it is e raised to power x. For x we'll have differentiation 1, it will be e raised to power x plus 1. So it will be e raised to power x plus 1 divided by differentiating the denominator independently, let us say it is u, it is v, and 3 is a constant here. So we'll put 3 out and differentiate the uv. First differentiate u, so differentiation of x is 1, x naught is constant, it will be 0, so it will be 1 times e raised to power x plus 1. So we'll have e raised to power x plus 1 and plus, keeping u same, that is x minus x naught times differentiating v, we'll get e raised to power x plus 1. For the differentiation of 1 is 0, while the differentiation of e raised to power x is e raised to power x. So we'll get e raised to power x. Now we'll see what happens when we use, let's first simplify it. And to simplify it, we have to multiply 3 with this expression and with this expression. So we'll get 3 e raised to power x times e raised to power x naught plus x plus 3 times e raised to power x plus 1 minus alpha e raised to power x plus 1 divided by 3 times. Similarly, we can multiply this 3 with e raised to power x plus 1 and with this quantity. We'll get 3 e raised to power x plus 1 plus 3 times x minus x naught times e raised to power x. Now if we use again the limit, x, when x tends to x naught, we'll see that this expression, this term becomes 0, because it becomes e raised to power x naught plus x naught, it becomes 0 because we already know that e raised to power x naught plus x naught is given 0. So this term is 0, 0 times anything is 0. This will remain and this will remain, and denominator, if we see it becomes e raised to x naught plus 1, this becomes x naught minus x naught, and it becomes 0, 0 times anything is 0. So will we remain with this term here and with these two terms here. Now if we put the value, we have to see what will the value of alpha, whether 2 or 3. Let us check first for 3. If we put alpha 3 here, it becomes 3 times e raised to power x plus 1 minus 3 times e raised to power x plus 1. They are same terms, so they will cancel. So in the denominator we will remain with 0 divided by, and will remain in the denominator with 3 times e raised to power x naught plus 1, because we have put x tends to x naught. So it becomes 3 times e raised to power x naught plus 1. 3 times e raised to power x naught plus 1, where we use alpha equal to 3. So 0 divided anything is 0, so we'll get the 0. Let us see for alpha equal to 3 whether there is a 0 or not. We see for alpha is equal to 3 and limit x tends to x naught, this whole expression tends to 0. So this is correct. Let us check for alpha is equal to 2. If we use alpha is equal to 2, let us see what happens. If we use now alpha is equal to 2 here, alpha 2, so 3 times e raised to power x naught plus 1 minus 2 times e raised to x naught plus 1. So will be 3 minus 2 is 1. So will remain with 1 time e raised to power x naught plus 1. Will remain for alpha equal to 2. Will be remain with e raised to power x naught, e raised to power x naught plus 1 time divided by, we have divided by 3 times e raised to x naught plus 1. 3 times e raised to power x naught plus 1. So this and this will go, will remain with 1 over 3. Let us check for alpha is equal to 2, whether it is 1 over 3 or not. If we see for alpha is equal to 2, we have given as 0 or 1. So but the real value is 1 over 3. So it means they are not correct. So A, B, D are not correct means that for alpha is equal to 3, limit x and x naught, we get g of x, but we get the value 0. So option C is correct.